The correlation is the same, and the linear regression is the same. So what would you expect? If we have the same mean, the same variance, the same correlation, the same linear regression for datasets, what would you expect if you would chart them? That they are the same. Would you agree? But they're completely different. So these datasets are completely different. Though all the statistics is the same. That's why not only the statistics, also the charts are essential for data analysis. Okay, so if you look at this data set, this is quite regular, okay? So let's say that here it would have a mean of y. We would uh, calculate the differences between mean, okay? And then we will do on square so that we get rid of the minuses, and that's it. This one, you see, it's completely different. This one is, let's say, pretty much linear, but we have a big outlier here. And this one, I mean, one outlier here. That's why you should always produce also the charts for in your analysis, never just statistics. Is this clear? And we will talk of three different libraries. Let me see if I'm already connected to. Yes, I am. Yes, I am. So is this one. Start. Okay. By the way, in the meanwhile, the deadline for your Python project will be next Friday. Okay, so you have more than enough time to produce, and you can take any data set as you want. I only provided you with these two data sets because sometimes students aren't really sure which data set to take. But you can take any data set. It is, let's say, I would really appreciate if you would take as many different data sets as possible so that you know the analysis will not uh, double, so we will not have duplicated data sets, okay? Okay, so now I
Excuse me,
guess,
Professor.
yes.
Professor, does the data set has to be clean?
No, it is, I mean, I would like that you should practice also the process of cleaning the data set.
Okay, so I search for the data set, but usually what the Kaggle shows is like most of the data are clean. So
That's
I,
true. That's true. That's true. Okay, you don't have only, for example, you can go on Kaggle. So probably most of you already are familiar with the Kaggle students, aren't you?
yeah.
Okay, so here, as I already showed you this Kaggle, you can find many data sets here. I mean, you can go through probably 30 data set. For example, see here, for you can, I immediately found a dirty data set. Okay, number of rows, 10,000. This, for example, would be probably ideal for really good training, okay? Then also you have probably data sets. No, data sets online for machine learning. Okay, AI data sets, open meta. So you have this as you would like. Uh-huh. Heart disease, wine quality, breast cancer. Okay. Look, this one, bank marketing. Um, these are quite big data sets. Okay, I don't want to you so that you overwhelm your computer. Go with something reasonable, okay? Don't go with like 10 million rows because probably you will have to then um, buy some cloud solution to analyze big data sets. You can go something between 1,000 and 10,000 rows. This will be quite manageable with on laptops. You're all having laptops, aren't you? So just look that you will not overwhelm, okay? Don't go with millions of rows. With between 1,000 and 10,000 rows. I mean plus minus, okay? So here you have, I mean, you will find as many data sets as possible. We will talk about this, what is actually the role of a data scientist at the end. Okay. So we have three different libraries. Matplotlib, which is the core of the Python. This is the core for creating charts. It is very flexible, very customizable. You can do anything you want, but I still think that the ggplot2 in R is better. Okay? Then you have a Seaborn, which is actually made upon Matplotlib, and it is meant to be simpler. Okay? It's based upon Matplotlib, but it tends to be simpler. So you have, for example, one function which creates charts. You can do much of the customization. I mean, the customization then has to be again done with Matplotlib. And then you have Plotly. I hope that I'm pronouncing this right because for all these years I'm pronouncing this as Plotly. Is actually interactive animated charts. So you'll see how beautiful charts we will make with Plotly. And these are also available in R, okay? Plotly is also available in R, the same. I mean the implementation of Plotly is also done in R. Okay, so how do we import these modules? Seaborn is always imported as SNS. Plotly Express always has px, and the class pyplot from matplotlib as plt. This is like a standard, industry standard. Okay, all clear until now? Okay, let me run it so that I import everything. And now I will load data. So I have a Titanic data and I have a Gapminder. You are now already familiar with the Gapminder dataset. The Gapminder dataset actually is a dataset where we can investigate the correlation between the life expectancy and different GDP per capita and countries and so on, so on, so on. Okay, let me now run it. We are already familiar with this one, and also you are familiar with this one. 117, 704 rows for countries from the year, I think, 1952 till 27. We have the data, and this will be today's data set. Okay, so if we run the matplotlib, okay, so this is the most basic plot that we can have. So what do we have here? Okay, so first we are importing our, we are already imported that above. Then we have what? What are these objects? XU venting. How do we call these objects? This object and this object.
List.
Yes. Okay, and then we are using the simplest plot. So this function will later you will see is the simplest. This is like a generic. I mean, it produces the line chart between X and Y. Then we are adding here the plot title and two labels. Okay, plot titles and two labels. And we are showing the results. Okay, so if I go down, I can see x-axis, y-axis. Okay, here we have the title, and also we have a grid. By default, we didn't do anything about the grid, but of course we can also address the grid in our matplotlib. So this is the customization. And it will be always, also if you will use the Seaborn, you will be able to customize the labels like this. Now let's go to the bar charts. Okay. So what does this code produce? Che, what does this code produce? Chain he. I hope that I pronounced your okay, yeah.
Chen, it's Chen. Yeah. Sorry, Professor. I don't really know.
You don't know. We did this like 2 days in a row. We are actually what? Counting, we're creating the frequencies by the classes, passenger classes. Okay, so if I class counts, okay, we're creating the frequencies. Okay, so this is actually sort index. That means that we are sorting them by the index, okay? Without this, ah, how are they sorted without sort index? Yusuf, how are they sorted without the index clause? descending order. Okay? In the descending order. When I produce sort index, they are sorted by the index. Okay, that's very simple. Now we get a bar chart. So you see what we have here, calling bar, X, Y. Then we have a title, labels, and this is optional. So how we want to address the colors? Without this, everything is like this. So all the colors are the same. Also, for example, will you notice any difference? Okay, so like this. Do you notice any difference? First, see, tick here, second, third. So we added labels to every class. So this is the way actually to start exploring also data. Now I would like to show you. So you can create here many different charts, okay, to visualize data, but Python has many different libraries that can help you to do exploratory data analysis. So one is SweetWiz, and the other there are many more, but these two are most famous one. Okay, I cannot install SweetWiz in Google Colab because of the dependency regarding the NumPy. It demands a certain version of NumPy which is not supported, which is not available on Google Colab. But I can show it to you so that you will understand what I'm talking about. What does SweetWiz do? Okay, let me see some images. Mm, mm, mm. Okay, let me see if this one is okay. So this is the SweetWiz. If you will install it on your local machine, it will work. Okay. So it creates the exploratory data analysis for every variable. Okay, so you see you get how many missing values we have, the distinct values. Then we have all these usual values like max, median, mean, interquantile range, Q3, Q1, and the median interquantile range, EQR. Then you have variance, standard deviation, kurtosis, and skewness. Okay, and also here. But not only this. This one is not the one that I want to this one doesn't have it. Okay, let's go to this one. Okay. Okay, so you can also define the dependent variable. Okay, so see the black one is the dependent one. Dependent. Dependent variable, okay? And then here you can find which variables have the highest influence on the dependent variable. Which independent variables? Okay, so the red one are the negative and this one positive. Okay, so with this you can already establish, okay, so this if the relation is positive, that means if x goes up, the epsilon goes up. If the relation is negative, the x goes down, the y goes up. The y. Okay? When we are talking about the correlation, can we talk about the causality? So that means, do you know what the causality means? Can we, with the correlation value, talk about the causality? Yes or no? Valentin, can we talk when we are calculating the correlation values? Can we talk about the causality?
Yes, we can. It's
No, we can't.
okay.
No, we can't. And I will show you now for example, the correlations without causality. Okay. Let me. Okay, so this is one of the uh, okay, for example, look at this one. This is a beautiful correlation. So what do we have? This is the number of movies in which Nicolas Cage appeared. And the red one is the number of people who drowned by falling into a pool. We have a perfect correlation, almost. I don't know what there the good correlation. So if I would say x would be a y, a would be, let's say, 0.7, okay? I would have perfect correlation. But is there the causality? Can we say that the number of movies in which Nicolas Cage appeared influences on the swimming pool drownings or vice versa? Come on, guys. Can we say, is there a causality?
Apparently, no.
No, there is no causality, just the correlation. So that's why you have to be very careful when you are analyzing data. Even though you get a nice correlation value, this doesn't mean that there is a causality. So, for example, this was now, you know that in the world right now, people tend to decline vaccination because they say that there is a correlation between vaccination and the autistic ratio. But the causality was never proved. Okay? So you have to be really very careful when you are calculating the statistics, that you know what you're talking about. Okay, let's look. There's one. Um, okay, so this one is also interesting. So we have per capita cheese consumption and number of people who died by becoming tangled in their bed sheets. So what would you say that the people who eat a lot of cheese, they used to get strangled with their bed sheets? Probably not. Again, correlation? but no causality. Okay. So that's why it is important that when you do the exploratory data analysis, you know how to interpret data. Okay, so we talked about the SweetWiz. We talked about how SweetWiz already produces which variables have the highest impact on the dependent variable, but it doesn't mean, okay, still has to be some theoretical background. This is a little bit different in data mining, but this is something that you will learn in data mining. Then we can, of course, install our data profiling. The data profiling works. So, okay. So now installed the data profiling. I will just clear output. And I will import, okay, from Y data profiling, import profile report. Okay, so you see there is a difference how the library is named and then how you have to, how the class is named. Okay, so you see there we have a dash and below we have underscore. Okay, so we are importing the profile report and I will say profile report. No, I will not do this. I will just do like this. I will create Titanic report based on the, is it Titanic? Okay, yeah, it is. So that I don't have to produce everything manually. Okay, so now the exploratory data analysis is uh, executing, is running. Just to be clear, if you will have a few millions of rows, this will take quite a while, okay? Quite a while. So then I get my data mining, my exploratory data analysis, okay? So I can see the basic statistics here. And then I go to the variables. You see, I can see the distribution, simple statistics. I can click on more details. I get more of the statistics, like categories, words. Okay, if something is connected. Okay, so here I get also word cloud, more details. You see words. Okay, which words appear most of the time. So you see the Mr. and the Miss and Mrs. Okay. And if I go down, I will come to interactions. Okay, so this is a scatter plot. Okay, I think that we already produced one of the scatter plots before. So here I have the interaction between H and the fare. Okay, what would you say? How would you comment this chart? If I would produce a linear regression, okay, this is over optimistic, but it would be something like this. What would you say, Elise? Can you interpret this scatter plot?
That there are um, more, no, the number of passengers are not really the causality of the fare.
So this is the H. So the age. If you look at the age, when the age increases, okay, when people become older, okay? What happened with the fair? It went up. So what does this tell you? This tells you that older people tend to be more in a first class. So if you look here, you see here we have quite a density of people, a lot of people. So we can specify that the majority of people, also if you look this part, okay, the majority of people actually bought the cheapest one, okay, the cheapest prices. And because of this density here, we can also speculate that most of the people were in less than 30 years old, if you look at this, and they were in the third class. So young people in the third class. And here you have the outliers. For example, you can see that there are very rich people, so probably these two had sweet. But you can see that with the age becoming higher, older, they tend to buy more expensive tickets. Okay, that's natural. Now let's look at no, this is actually the okay, yeah, we can also look at this one. Okay, so see, this is not actually the okay chart, completely inappropriate chart, but nevertheless, we have it. What can you tell me about this chart? So we have the number of siblings and the age. Okay. Tingy cow. What can you interpret from this chart?
Most people don't have siblings.
Yes, that's true. Most people don't. If you go and also when they are getting older, okay, you see, for example, yeah, like you said, most people don't have any siblings. And if they have, most of them had one sibling, maybe two. Though
Yeah.
there is some of the exceptions regarding the four, but otherwise, yeah, most people don't have siblings. Then we have the correlation. Um, did you already talk about the correlation in the data mining class?
Yes.
Yes,
Yes.
just today.
Yes.
Yesterday.
Just today.
Yesterday. Okay, so
Not today. Today.
today.
Yeah, just today, I said.
Just today. Okay. Yeah. So you understand the correlation now. Did you produce any like this heat map?
We were just using one card data.
One
So
empty car or car.
no, car with a different specification like speed, power, and other things.
Yeah, power. Yeah, that's empty car data set.
Yeah.
Where you have
So
power, weight, number of gears, cylinders, that one,
yeah, yeah,
and miles
yeah,
per gallon.
yeah.
And
So
only 32 rows. Only 32 different cars.
the data set was quite small. So
Yeah, only at 32. I know because I'm working with R more than 10 years, like 16 years. So I'm pretty much familiar with empty cars dataset. Yeah. I mean for data mining, yeah, okay. So here again, just to go quickly through, the color tends to show us the correlation strength. You know how to read this. You go, so the survived. Okay, so here we have the sex. Okay, so because we have 1 and 2, 1 being male, 2 being female, this is getting, like more blue. So that means that people tend to survive if they were female. Okay, so we have also here fare and passenger class. So this is it, how you read the correlation matrix. Also the missing values, okay, sample, just a sample. So this is what you do with simple exploratory data analysis. On Monday, I will also show you how you can do the same thing in R. Because before you start any analysis, you have to do exploratory data analysis. Is this clear? Why data profiling? SweetWiz is more powerful. If you will use more than 10,000 rows, this will take a while, but it will produce the result, okay? It will produce the result. Okay, so we already talked about this. Sometimes you will want to flip the plot. So this one is the horizontal chart, you see, bar horizontal. So instead of like up, it's horizontal. And who will explain me what we get here? What n largest does? Furia Yashvi. What n largest method does in Python?
I have no idea about this. Sorry.
Well, you had to do this yesterday.
Mm, I'm sorry. I didn't get the time to do it. Sorry. Yeah.
Okay. This one returns top k. Okay. And in this case, we are getting back 10 countries, top 10 countries by life expectancy. So let me create code here and do this. Oh, yeah, of course, I must also do this. Okay, so you see, these are the life expectancy from the year 27. I could go, for example, only at 5. Okay. In R, we will do something very similar, which is called slice max and slice min. So in R, it would be like this, slice max. The bottom slice min. Dot n largest. Okay. So we are then creating the chart. Do you find this chart okay? Tapa Milan.
Yes, sir.
Do you find this chart okay?
Everything looks similar, but
Exactly. Okay, so now you have two options. Okay, so it depends on what you're trying to show. If you're trying to show, for example, that everything looks, that the life expectancy of 10 countries with the highest life expectancy are pretty much the same, then you would start drawing from the zero, okay? You would start drawing from the zero so that you can show the reader, okay, there is not much differences. But if you would like to show that there are differences, you have to limit, not 40, 90, I will say, let's go with 70 and 80. Okay. Oh, not 80, 85. And maybe 75. So that's okay. So now you can see that we did emphasize the differences. So it does depend of how you will choose how much data will you show. I mean, the scales depends on the problem that you are trying to tackle, to explain. Okay? So we did here just the limit of the x-axis. Clear? Then we have line charts, which are, we already got familiar. Again, what is new here? So x, y, the marker, okay? Now let's run it. Okay, so we see we have color green. We can live, I could say probably X. Let me see if X will work. Not all characters work. Okay, X works, you see. Now we have X, I could say blue. Okay. So what can you tell me from this line that the world population exploded? You know that everything in nature tends to have um, I mean all the growth has the form of the hockey stick. For example, the population. When human appeared like this, and then it was a boom. Okay? So, I think that in 19 1800, I'm not really sure, but there were less than billion people. Okay? I think there were less than billion people. And then it exploded. So, you see, has the hockey stick. Also with the AI, it developed like this, and then it exploded. So this is like a law. Let me just check. Uh, Number of people of world population in. Okay, let's go with AI mode. Okay, so you see the estimation is 1 billion. So in the beginning of, let's say, less than 1 billion. In Africa, only 9 to 100 million. I mean, it's crazy. Okay, so yeah, look at the China in India. Okay, what do you think happens if the population is growing too fast? The infrastructure just can't cope with the growth. It can't. The number of schools, the number of teachers, doctors, uh, apartments, it can't. Okay. Now let's do more advanced. Okay, so how many dimensions of data are we showing here? We have year and we have the population. So how many dimensions?
2 dimensional.
2 dimensions. Yes, 2. Now let's go and add more. Okay, so we are going through we are preparing the continents. And for every continent, we are producing the plot. See, we are actually here, we are producing the line plot. Okay, continents. I mean, it's so simple. Uh, we just do the for loop. We do the filter by year, and then we are just plotting this on the same chart. Voila, and here we have our chart. So how many dimensions do we have here?
Still 2?
No. This is additional one.
3 dimensions.
3 dimensions. Yeah. 3. Do you find this chart nice?
Yes.
I think it is. I mean, we didn't play with colors, but I mean, I think it's pretty much nice. This is the default. I must say that default colors in Python are much nicer than in R. You will see in ggplots too. Okay. Then we have histograms. You know what histograms are. We already talked about the histograms. They represent a distribution. So in our case, we have a quite large population of very small very young passengers. At the highest is at 20 to 30 years old. And then we have a few of very old people on the our Titanic. We can also go with multiple groups. I don't like to use this kind of histograms. Okay, but this clearly shows what? Clearly shows that here, this part, so survived was quite high. Okay, and this one was pretty much high that did not survive. Also this one, you see? Here we have a few very old people. Probably these are, the most richest one who got the seat on the rescue boat. Scatter plots. We already talked about this, but we have here another dimension. Okay, so how many dimensions do we have here? Okay, I
Three
will
dimensions.
3 dimensions. Yes, I will remove this one. Okay, so what do we have here? Let me decrease a little bit. We don't have here. This is in 2007. What do you think this is? And what do you think this is?
It's a cluster.
I mean, you could say it is a cluster, but not a cluster in a data mining way. This one is China, and this one is India. So the size of the bubble, you see, is actually the number of people in millions. Okay? So here we have three dimensions again, GDP per capita, we have life expectancy, and we could add something more. I could say add on amount country. So I would like to add no, 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 no. This is not what I want. This is the interactive chart. Okay. Okay, but let me just run it. So you will see this is just a line chart, but it's not what I wanted. I wanted to add the label here, the Hoover, and it didn't actually produce me. So that I would label this is a China and this is the India. I could also add here uh no, that wouldn't be the best. Definitely it should be like, I don't know, maybe the interactive one. I don't know why it
Maybe
didn't.
you can change the colors as well.
Yes, you call, of course. But you know, like there are too many countries. So if I would change the colors, then it would be like a Christmas tree, you know? Not very informative. Not very informative. We will do this later with these interactive charts when this will be clearly visible. Okay? Let me just check something. Check. Probably the scatter plot doesn't have this. You know, I never do this actually. Does this chart have on mouse Hoover parameter? Probably not. No, does not have Hoover name. Unfortunately not. Okay. Only the Plotly. So this would be much nice. It would be nice to have here also on the regular, not on the interactive one, the name. Or I would have to change the type of a chart to completely different type. We will do that later, okay? Then we have subplots. This is nice somewhere. So in that case, we are configuring, this is a row. This is column. So we have one column, one row and two columns. So this in practice means like having two charts side by side. This is much nicer than in R, I must admit. Okay, two charts side by side. So the first one is which one? Liao, you. Which one is the first one?
Um,
Just the type of the chart. I'm interested into the type of the chart. Just read. It says. It's written.
the bar,
Yeah, and the second one?
his,
Yes, histogram. Okay, so if I now run this, I get two charts side by side. And you see, actually, I am just, like when I create subgroup, okay, I'm actually creating axes, okay? So see, this one is the first one, this one is the second one. And then I'm just, like, I have additional layer. How do I address the properties of chart? Additional layer, not directly to title, label, Y label. Okay, title, X label, Y label. I also have to specify the axis. Okay, additional layer. So the first one, then the second one. Okay, this is all the difference. Okay, maybe a little bit of the difference in the syntax, but otherwise it is quite similar. If I would produce, see here I have Y label, X label. Here I have the word set. Okay, because I am trying to get to the titles and the X and Y labels through the axis. That's the only difference. And you can create many different nice charts with combination of other charts. We already talked about this one, so see marker size, marker, I mean, nothing special. Of course, here color label is part of, okay, still something not red, font size bold, marker, what did it say? Back the keywords marker. Marque. Okay, here. This is probably still part of the, okay, I will just remove this. Ah. That one.
My line is the label.
Yeah. Legend label, yeah. So that's it. Label, marker, size, that's everything. It is okay, accept. Okay, so now it is customized plot. My line, label. I could set the position of this, I could change this and set it somewhere else. And that's all. I mean, pretty much straightforward. If you look at the matplotlib, it has a very big support on the internet. You will find here, you see all this different stuff. See here we have special plots. Okay. We talked about this SNCOM quartet, you see. You can do the diagrams. Okay. See, you can do all this here. I mean, it's not easy. It's not easy, but it's manageable. Okay. I would definitely, for example, for something like this, I would find a library module who is based on matplotlib that does this okay. For example, if I ask AI, I could ask AI and say, okay, let's go to Gemini. Gemini, is there any module in Python based on matplotlib that produces, okay? Okay, so you see a big difference. Now let's look this one. So only this. This is definitely on the, let me try to install it, okay? Probably I will not be able to do it because I don't know what are the dependencies. Let me just try it. Pip install. Okay. Well, we managed. I'm surprised. Okay, where are you? So then if we take this part and put it inside here. Okay, yeah. Something is missing. See, I have to call the matplotlib. So yeah, subplots, Ishikawa. Okay, let me see. Still not. Okay. Let's accept and run. Yeah. Now we have it. Okay. So we did this and now compare this to this. Okay, because you see, I never done this till today. Never. But when I saw this Ishikawa diagram, my first thought was, okay, there must be a module based on the matplotlib that helps me build this Ishikawa diagram. Put it into Gemini. Gemini produced me the name of the module, put it in, 2 times I got error, and now it works. You see, this is the way how you will actually work in your private sector in real life scenarios. Okay? And I find this pretty much, okay, simple. If I put it, okay, if I copy this, I can say Neoma. I will say sessions, live sessions. Voila. Do you find this okay? I mean, the chart. How do you find the chart? Is it okay? Elise, what is your opinion?
Yes, it's okay, but can you show me, please, the beginning of your code? Thank you so much. Thank you.
Is how to study. Okay, and this is now how to study for, okay. Now we go to the C-boron. As I already explained, the C-boron is actually based on the matplotlib. Just like in this case, MQR is based on the matplotlib. Here, the C-boron is based on matplotlib, and it is intended for statistical analysis. Okay? So here, for example, we have count plot. Just see here that we are not doing any pre-calculation. Before here for the bar chart, we did class counts. So we did the value count. So we did the frequency distribution. In this case, we are not doing any pre-calculation. We are just invoking the count plot, X class, okay? And then here we will get the bars. Here, these are the bars. This is just the name of the color palette. And then if I want to do the customization, I still have to invoke matplotlib functions. Okay, so how does this look like? Voila. So I have P class, passenger class, survived, yes, no. Okay, I could, if I would add, let's add sex. Probably this will, there will be an error or not, we will see. No, just male and female. Okay, and yeah, that's it. P class. So we got simple. Without any pre-calculation, we get the results. Okay, so then we have box plot. So you already are familiar with the box plot. Did you have the box plot today? Today or already prior with Professor Balash?
We did in both of the class previously also, and yesterday's class also, like last class on Tuesday also.
Mm-hmm. Okay, so then you can tell me what is this? Prince Joseph, what is this? Noah, what is this?
Um, the repartition of the survive the people who survive by age and class, no?
No. I mean, what I've labeled here with these arrows. From here to here, what is this? Who knows?
These are the quartiles.
Quartile
Yes,
20.
yes. Interquartile range. EQR. Okay, so this is the 25th, this is the 5th, our median, and this is the 75th quartile, okay? And only looking by this, you can already see something. For example, if the median is in the middle, that means that probably you have, let's say, normal distribution. Not always, but probably. Okay, so if the median is up, you see, we have a tail on which side? If we would calculate, what should we calculate? Okay, so the most not optimal way would be to take what? So this is our Titanic. I would say where we have the P class is, I will also say Titanic. P class is 2. So in that case, I get what? Now I have this. Do you agree? Okay. I'm only interested in what is that survived? Yeah, survived. Okay, so this is a series. So what do I have to calculate? And what? I should also add, come on guys, these are now the essentials. So after 15 hours, you should be able to produce something like this. Survived 0. And I'm interested in age, and I will put double brackets, so I will have a data frame. Yeah. 2 equals science. Okay. And if I say so, what are we looking at when I am showing you this one? A person around here.
Outlier, Professor.
Sorry?
Outlier? No.
Yes, outlier, yes. Okay. So what I did here, what we learned 2 days ago, you see, just using the filters and the 2 square brackets so that I didn't get the series, but I stayed in a data frame mode. If I would calculate skewness, this should be what? Positive or negative? Christille.
Yes, it should be negative.
After all this time, if we have a tail on the right side, the skewness is positive. If we have a tail on the left side, the skewness is negative. See, it's positive.
Oh, so positive, yes, right side.
Yeah. Then the violin plots. Okay, so what do we see in the violin plot? Can somebody tell me? So if you would flip the violin plot like this, you get, like distribution. So here we have a long tail H, you see? So it should be like this. Okay, these are the distributions. With additional dimension by sex. Okay. We already talked about this. Then we have a scatter plot with regression. Okay, you see, probably, I mean, there is a really, really almost no linear regression. If we wouldn't, okay, why do you think that this curve line is up? What tends to draw this line up? This. Okay, most of the people are in a third class. You see? And the heat map, we already talked about this today, and you are already familiar. So see how simple it is to create a heat map? Just one simple line. And if I want to customize this, I have to, of course, call the matplotlib. I suggest that we have a break for 15 minutes. Would you agree? Okay. 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 Oh, the resume the recording. Okay, so it was paused. We will talk about the facets also at the ggplots too. And I definitely must tell you that the complete lookout, the complete forum of the graphics is more beautiful in Python than in R. Okay, so we went through all the C-boron charts, which are most important. Now we're going to the interactive charts, okay? So you will run it with px, okay? And let's look at the interactive bar chart. So it's very simple again. You see, I'm only calling the bar px.bar and I'm specifying the data, the X class, the survived class, table labels, survived, and that's it. That's it. And I get a whole interactive chart, which in this case, why is this now not working? P class. So apparently my Titanic dataset is broken. Okay, let me run it again. Where are you? Okay, here you are. Okay, now this works. Now look, I mean, here the interaction isn't really necessary. We have three bars. I can, like do the zooming. I mean, it's not something I would do. Auto scale back. You see, I can move it around. I can download. Okay, so you have the downloaded chart. Okay, now look at this one. This will be much better. So what do I have here? I am again subsetting the year 2007 from the gap minder, and I'm doing the scatter plot. And here you see I have this hover name, the country. What I've missed before, I will put here false and run it. So this is in 2007. So if I click here, so you see, I see a China and the GDP per capita is $5,000. Probably it's in dollars. And the life expectancy is 73 years almost. Here is the United States and the GDP per capita is $43,000 and the life expectancy is 78. Probably now in 2025, this is probably higher, though there should be, you see, we have Kuwait, so the life expectancy is a little bit lower. GDP per capita is larger, so Singapore, Norway. So you see life expectancy 80 years. Okay, something here. No. No, 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 no. Ireland, Hong Kong, you see. Netherlands. Okay. Now look at the bottom side. So Afghanistan, you see the life expectancy, 43 years. That was in 2007, so probably now it's higher. Sierra Leone, okay, Congo, Myanmar, and we have here the India. So 65 years in 2007, GDP per capita $2,400, and China is okay, I already said $5,000, 72. Okay. So if I now just rewind this back to the 1952, which is the first year of the Gapminder. Okay, now you see, I don't know if, okay, let me see if I can do this here with I'm not sure if this will work combining. So I will say only from 0 to, okay, let me see if this will work. Yes, it does, but it didn't change anything. 20 GDP per capita. No, it actually didn't work. So it does not work. I cannot.
Excuse me, Professor.
Yes.
Professor, can you explain what that log x equals to false does?
Yeah, okay. So because you see the x-axis is very high. I mean very, very big compared to the life expectancy. You can see that we are having here $100,000, okay? If I do the logarithmic operation, okay? So you see, it's much more, let's say, the data, let me go to 2007, much clearer, okay? You can see the data is much more spread across the x-axis, okay? It's not that dense. And you see here we don't have again more those 100,000 because we are doing actually the logarithmic operation. Let me calculate. Okay, let me ask the Gemini. What is the log of $100,000? Okay, let me see. Okay, so the natural log is 11. The log on the basis of 10 is 5. Okay. And this is a little bit strange here. This one here, 9, 1,000, 10,000. I would probably need to remove this. I mean, it's very hard to interpret when you have a logarithmic scale, you know? Much easier to interpret data if you don't have logarithmic scale. Though in this case, you see, everything is moved towards the zero, okay? A little bit towards the zero. Logarithm is also used when the distribution of the variable is not normal. So you can use the logarithmic transformation, but as I mentioned before, it is more difficult to interpret the results. Okay, let's go to, again, 52. Now you see everything is here. Okay, now if we look at the India, so in 52, the GDP per capita was $546, and the China 400. And the life expectancy 44. In the India, 37. Okay, here the Ethiopia 34. And the Afghanistan only 28 and 52. On the other hand, the United States 68. So you see how actually the life expectancy increased during the years. And if you want to create, let's say, if you want to impress the public, you can do the animated scatter plot. Look at this now. So I'm adding the animation across the year and animation group across the country. So that means that also the bubbles will change. Okay. I will put this into the false so that we will have a linear scale. Okay. And here I have the play. So you can see. I will change this. No, I cannot. I already said this. Oh, yes, I can. I can say here range X would be until 50,000. Okay. Now let's do this again. Okay, I could go until 45. If I would remove this, I don't see any difference, if I'm honest. Do you see any difference?
No, there are no difference.
Yeah. Okay. So if you want to impress, for example, people, you can do this animation. You have like 3 dimensions. No, 4 dimensions actually. You have GDP per capita, you have life expectancy, you have country, you have continent. And the size of the, okay, 5. And you have 5. The fifth is the size of the bubble, and it is the population. Okay. So I could also say what? Gapminder. And I will do Gapminder. No, not here. I will say continent. I will say Europe. And I will say GP Europe. Okay, let me see. So I will need this. So the continent will always be the same. Okay, let me just see if this will. Wow, there is something out of the scope. Color will say country. Now this will be very crowded here. Okay. United Kingdom, France. Okay, let me. France is yellow. Well, that's strange. No, in France is not yellow. Okay. Probably this is Liechtenstein. No, Norway. Okay, so I see Norway, Ireland, Netherlands, Switzerland, Germany, and France. Yes, it is. Okay, so in 2007, the life expectancy was almost 81 years, and the GDP per capita $40,000 per $40,000. Okay, so which one is the Albania is the last one here? But see, it isn't such a big difference. So in Albania, 76 years the life expectancy. Is this the lowest one? No, it's actually Turkey. It's 71. And the highest is what? Spain, 81. Switzerland. Okay, so where is Slovenia? Austria? Ah, Slovenia. Should be a very, very small. Here it is. Okay, so the life expectancy almost 78 years and the GDP per capita 26,000 euros. Okay, so yeah, quite behind the big Italy. Okay, so you can then just play, like with this. Okay, let's look at the Asia. Okay, Israel, Japan, Korea, okay, Saudi Arabia, China, and Afghanistan here. So this is the way how you can actually play. Is this difficult? Probably not. Would you say it is difficult? I hope that you will not say that this is difficult.
No, it is not.
Yeah. Okay, so interactive line chart, which is, I mean, this is garbage, if you ask me. Also, the interactive histogram, I mean, what I can only do like this, and then I can inspect a certain bin. Okay, otherwise, no use. Box plot. I mean, if I okay, so I have the all the numbers that I need. Otherwise, I would still go with non-interactive. Then we have this one. This one is nice one. You will see. So this is a map of our planet Earth. This one is still free on this map. So the Greenland is still, let's say, not under the United States. Okay. No data also for the Soviet Union, because here all the Soviet Union countries are. And of course, no data for Antarctica. And again, you can click on it and you see immediately the life expectancy. You see, the more towards the dark green, the highest the expectancy. You can see that the Europe and the Canada, but you see the differences isn't that big between Canada and the United States. It's like, okay, Europe is, let me zoom in. So in Europe, you can see that the Switzerland, Italy, so here is a Slovenia, a little bit lower. Okay, so Romania, 72, 71, Poland, Now this changed quite a lot. So, okay. And if we go to Africa, so Libya had the highest, 73, almost like it's almost the same as in Europe, the Saudi Arabia. And then this on the equator, we have more not that good data. For example, look at Sierra Leone, 42, Guinea-Bissau, Angola, 42, 43. But do you remember what was the average life expectancy in Afghanistan in 52? Do you still remember when I showed it to you? 28 years. Okay, let me look.
45 something.
No. In 1952 it was 28. Look. Now we have this, you see? This was in 52. This is in 52, and if you look at the Afghanistan, it's 28. It was 28. Nepal, 46. India, 37. I mean, these are, let's say, catastrophic numbers from today's perspective. Would you agree? Like, if someone would say, okay, you will only live on average like 47 years. So I would be dead like now for 14 years. You know, but yeah, I mean, but this is mostly, why this statistics is as it is. Again, you have to be careful when you read the statistics. If I tell you that the average life expectancy in ancient Rome was 25 years, it was 25 years. But this is mostly on behalf of the children that died at birth and in the first year. Okay, so they tend to put the life expectancy towards down. Okay, you still had a lot of people who lived till 80s, yes, 70s, 80s. Okay, but like because there was a high mortality between children in the first year, the life expectancy went down. And yeah, so in Slovenia, it was 65. Okay. So that's why you have to really interpret this data very carefully. If we look at okay, let me check. So let me go and see life expectancy across Europe in 1800. Okay, let me see. Okay, let's go into this mode. So you see, Russia, 28. So child mortality, okay? You still had people who survived, like the youth, okay? So the early years, they still tend to live till 60s and 70s, okay? That's why we be very careful when you interpret this kind of data. Okay, so when you will do your analysis, always tend to select the right chart. And usually the most awful charts is the pie chart. Do you know which chart is even more disastrous compared to the pie chart? 3D pie chart. Okay, so 3D pie chart is even more awful than the regular pie chart. Here I will show you a complete guidance. Okay, so this is from the R books repository, bookdown.org. You have data visualization. So this is, like a complete separate individual field, how you must present your storytelling to the reader. So what kind of colors, like you have to choose the colors that colorly blind people will still able to see. Okay. This is very important. So here you have a book. Okay, let me give you the link. Okay, so for example, you see these are actually default ggplots2 charts in R, and they are awful. Okay. I also like this one, you see? These are the default colors. I mean, do you find these colors okay? I mean, I think that the default Python colors are much prettier compared to these colors. What would you say? Okay. So it is important that you choose the right chart and avoid 3D charts. I mean, these are pie charts with many slices, rainbow color schemes. Okay, do clear labels and titles. And when you present a data story, you should always answer to a few questions. What are you trying to answer? What are the evidence to support your hypothesis or your thesis? Which visualizations you will use, and what are the insights? And the deadline will be next Friday. I will put this also into the Moodle. And yeah, these are actually, then you have to present the storytelling, you have to do the explanations, so that the someone who will read your document will understand the problem. So focus on the definition of the problem, your hypothesis, your data, how you will present your data, how you will choose the right visualizations, then do the discussion and the findings. This is usually how you do whole storytelling. And now let's go to our Titanic. Okay, so let's run it. So these are the Titanic P classes. Let's look at the concatenations. Independent variable, these are the standardizations, you see? So this is standardization, so that not, for example, a variable with higher, bigger scale will not prevail in the model. That is important. Also in the data mining, this is very important. Now we have here the logistic regression. Okay, and let's calculate and explain the correlations. Okay, so if you now look, do you remember what was who actually said regarding the what influences most on the survival rate? Who was that? What was actually the statement? That the sex influenced more on the survival rate than the passenger class. Was that the statement, if I'm not mistaken? I think it was. Okay, now look the standardized correlation, okay? So look at this one. So this definitely had the highest survival impact on the surviving. 54% positive correlation. Being female strongly associated with a higher probability of survival. Okay? Then we have P class 2. This is a weak positive correlation because the base reference class is P class 1. So it's 1 for second class and 0 otherwise first. This suggests slightly higher survival probability for second class passenger compared to other classes. But the effect is not very strong on its own. And then the third class, we have a negative correlation. Okay? Moderate negative correlation. So that means that being in a third class passenger is associated with a lower probability of survival. The negative sign implies that as class P increases, the survival tends to decrease. Okay, so the partial correlation, then we also have the partial correlations. Okay, this is the explanation and the discussion. Okay, this is the logistic regression. So females were about 3.45 times more likely to survive than male. You see? This is a logistic regression, 3.45. Okay, second class passenger were about 0.80 times as likely to survive as the first class passenger. And this means that the third class passenger were only about 0.42 times as likely to survive as the first class passenger, holding sex constant, okay? So this is now the whole analysis. The whole analysis. Now just remember, you could put in bank data set. You could analyze it like this. I also prepared the Gemini application with React and Python. Okay, so this is a nice Gemini, React. Okay, how can I? Okay, so I cannot. So you see, with a nice dashboard and feature analysis, okay? So you can analyze the features, model training comparison, blah, blah, the prediction. So what do we have here with the prediction? Look at this one. This is a simulator. So you can do this with every data mining model that you will have, okay? You can do the prediction simulator. So if I choose the first class passenger and a female, and I will decrease the age, and then I will calculate the survival probability is 99%. Let me put this to, let's say, 37. It's a little bit lower, but still. Okay, let's go into the second class. It's 92. Now let's look at the male. Only 50%. First class, 73. Third class male. Okay, let's decrease age to. Still, okay. Let's make them older. Only 27. You see? Now this is a simulator. And what I did was I said this was my prompt, which created this. Okay? This is the code then created. Preview. Do you find this dashboard nice? and the simulator. Okay, you
But
can
it is
then
good with the open source. Sorry to interrupt you,
yes, it
but
is.
it is good with the
No, I mean yes, it is. But not all the models.
but open source data it is fine, but in the closed source data like we can't use, right?
Yeah, that's true.
Maybe in future few tools will come with AI.
You can always, like, just imagine you coming as a internship with all this knowledge, and you do the analysis of the company's data and present them like this. Probably they will be blown away. Okay, they will be blown away.
Yeah.